So let's have a look at the circulation in estuaries. And we are not talking about the tides, because what the tides essentially do is they just move water in and out, in and out, in and out. So they don't produce a net movement over long distances in an estuary. So what creates this movement are the horizontal pressure gradients. Okay, so there are two different types of estuaries, and the circulations are different. And here are sketches that cuts along the estuary, and you see a vertical transect. Okay, and in a positive estuary, we have an outflow of low salinity water in the upper layer. Okay, it's essentially a pressure gradient that pushes the fresh water towards the ocean. Okay, all right. So, but on the other hand, we also have an inflow of seawater. There's a density difference, a horizontal density difference, that actually creates an inflow of seawater into your estuary. I mean, that's the interesting bit, the seawater flowing in the bottom layer. So that's the structure in a positive estuary. In an inverse estuary, the structure is different. Here, the heavier hypersaline bottom water flows out into the ambient ocean near the bottom. Okay? And it draws in water, seawater in the top layer. Okay? So that's the difference between the circulation in positive and inverse estuary. Okay, and that is important to learn. Okay, that's an important to learn because the inflow of seawater actually provides a means of flushing. We call it flushing, essentially because if you assume that the seawater is clean, the clean environment, it actually brings new seawater, unpolluted water into your system. Whereas the river water can be treated as impacted by human activities. Okay, so that it's important to understand the circulation in estuaries. Hooray!